Hello, this is Benign and welcome to my channel. So a couple of weeks ago I published my completely first tutorial, which was about cable generator. And the setup was based on the Plexus Effect that is well known in the motion design, motion graphics community. But thanks to YouTube algorithms, pretty soon I discovered that there is a much better way to achieve this Plexus Effect, which makes the whole cable generator run faster. So in this tutorial we will redo the same thing with a slightly different approach that is faster, simpler, and scales better. So stay tuned. I prepared this scene to compare two setups. Here we have 8,600 points, and we generate Plexus Effect with the two different approaches. The lower one is what we had in the tutorial, the upper one is the new one that I discovered, and we can compare them. So we can see that this one takes 485 milliseconds to generate, and this one is 340. But if we scale the number of points to, let's say, 600, let's see, 1000 milliseconds for the new setup and 1300 milliseconds. So it's like 30% more efficient, which together with other tweaks will make the whole setup much more responsive. So let's quickly discuss what it is this new approach and where it came from. Before we begin, I want to shout out and give credit to this guy. I guess his name is Ilir Bekiri, who published his video 5 months ago, where he explained his approach into making Plexus setup. And the key difference is that he's not using any repeat zones or iteration like for each. So I will quickly draw the difference. Like in my setup that I was explaining, let's say we have a bunch of points like this. We iterated over each one of them. So when we were running over this point, we were creating the connection to here. But when we were iterating over this point, we were creating another connection here. So basically, we were generating double connections, and the amount of computations was really huge. But he came up with very interesting concept that if you have a couple of points, and we can number them 0, 1, 2, 3, 4. And the idea is very interesting. I didn't think about it before. Like if you want to connect each point to each point, the number of connections that we have to do, absolute minimum number of connection, will be equal to the number of the point, basically its index. So for this one, we create 0 connections. For this one, we create only 1 connection. Sorry, let's make it more straight. For this one, we can create 2 connections. For this one, we can create 3 connections, and vice versa. And it's quite interesting concept because it allows us to only generate connections that are absolutely needed. So let's dive into the setup. The first part of it will be completely the same as in previous tutorial, but I still want to include it here. So this video will be also complete. You don't have to jump between the two. So we are starting with empty scene, and I have screencast keys also enabled, so you can see what I'm pressing on the keyboard. I will take the camera and delete it because we don't need it. We'll take the cube and create new geometry nodes modifier. Let's cut the connection and make some room. We will start with the curved line. That will be stretching along y-axis. So we can take the value to control the lens, combine XYZ, plug it into Y, let's say 2. Here, let's plug it here, and this one we can scale to -1. And we have a line. I move it around so you can see it because it's collapsing with the axis. So we have a line that is twice of this length. So we can say 3, so it will be 6 meters, as you can see. Then we say mesh to curve to mesh. Curve to mesh. Plug it here. We need the cross section. We'll say circle. Curve circle. Let's plug here, and we have a tube. And we can say fill caps. But in order to define start and end points for our algorithms, we need to have these caps as a separate object, so we can scatter some points there and control. So we can do curve to points, take our initial curve by count. If we say 2, it will give us start and end point, which we don't see right now in the previewer, but they are there. And then we can do instance on points, take our curve, and let's plug also rotation. And the last thing we need to do is fill the curves. Let's do some housekeeping so we understand our setup better. And let's move this aside. And we can say make some organization also. So let's go back to our mesh. We can do mesh to volume. And then distribute points in volume. Let's preview. We have the points. We can push the density of the volume a bit, so it's filling more space. And we can up the density. So these are our points. Let's work with these guys. Right now we have 2 instances. So if we do distribute points on faces, we get the points, but interesting thing that it's still an instance. So let's up the density. And then we can do interesting thing. We can do separate geometry, and we can plug index into selection, because the index of these guys is 0 and 1, and we have to say instance. And this way we get the start and end points. But let's go back here. We need to join our points, all of them, with these guys. But as you remember, these guys are instances, so we can realize them here. And we should get our point cloud. Let's play a bit with the densities. So let's use maybe 60 here and 100 here. So we have more kind of uniform distribution. So at this stage, we start with the Plexus effect. I'm gonna decrease the density of the points so our setup runs a bit faster on my slow machine. And we can begin. So as we previously discussed, we need to define number of connections per point that will be equal to the points number in the list. Basically, it's ID, it's index. And we can do this by copying the points, the number of with the copies equal to the number of index. I don't know if it makes sense, but let's do it. There is a node called duplicate indexes, element, sorry. We plug it, and as an amount, we will use index. So this way, point number 0 will be copied 0 times, point number 1 will be copied 1 times, etc. And here we have a field that will tell us the number of the copy. So if the point was copied 5 times, it will go from 0 to 5, let's say. And we can use this to find the index of the point. We can use this as an index to find the position of the original point. So this way it will give us the target. So I hope it makes sense. But we can do sample index, take the original geometry, but take indexes from here. And we need to find the vector value, and field we need to evaluate is position. This way we get the position of the target point, while this returns the position of original point, the starting point. And if we subtract these two vectors, it was, vector mask. If we subtract these two vectors, one from another, it will give us the vector between these 2 points, the starting point and the target point. And then we can measure the length, which will give us the distance between the start point and the target point. And what's cool, if we then take instance on points, plug it here, there is this selection field, and we can just measure with the compare. We need less than our distance and filter by distance, so we don't do any instancing on the points that are further away from our current point. So this is the distance field filter. Then we need to create line that we will instance. Mesh line, we plug it here, and we have our instance lines filtered by the distance. So the higher the distance, the more lines we get. Let's go with 0.1 for now. Another thing we need to sort is rotation. And what's cool is that we already have the vector, so we can use align rotation to vector. Take our vector and use the axis because our mesh line is going along z direction, and plug it into rotation. And this way these lines will be rotated towards the target point. Next thing we have to sort is the scale, and that is easy because we can use our length as a scale if we assume that the line is one unit long. So let's plug it here. But there is a small problem because we need to adjust our line based. We need to use not offset but endpoint, so the line will be 1 meter and width 2 points is enough. And then we can play with the distance. And we have our Plexus effect. And as you can see, it runs super fast. So this is where the difference between this tutorial and the previous one ends. Again, because what we will do next, we already did before. It's the same shortest path distance setup. I'm gonna lower the number of connections to maybe 0.3, so it runs a bit faster. What we need to do is realize instances to have a mesh, and we also need to merge by distance. Merge by distance. So we have merged paths. And here we need to do repeat zone and create our messy setup. So let's plug our geometry and let's continue. So what we need to have is these guys, start and end points. We need to have shortest edge paths and add pass to curves. Plug this guy here. This will be our mesh, and this we output as a separate input, and we also need to merge it. with the previous iteration. Join geometry. So we have these two guys, and we need to do realize instances twice. Here and here. So completely first thing, we need to pick our random points to be the start point. And we can do this by random value, switch it to integer, and run from 0 to the maximum index, which we can get by domain size, which we need to switch to the point cloud. And we need to do the same here. I'm gonna cut the preview. And we need to use iteration number as a driver for this operation. I'm gonna make some more room. So with every iteration, we get different points for the start and for the end. And this gives us the index of the point, and we need to find its position. So we can do sample index. This will be our index. This will be our geometry. We can do it like this to make some room. And we need to find vector value of position. And we do the same thing here. Position. Geometry. So this gives us the position of this random point. And then we can do sample nearest. Based on this position and based on this geometry. And we can do it like this. And the same thing here. Let's do a little bit of organization. And we have an index of start point and index of end point. And we need to compare integer because these two nodes, as input, they need a list of true and false because they can use more start points and more than one endpoint. But since we have only one, we can compare index of all points with the index that we just selected and switch it to equal and do the same thing here again. And let's plug it here and let's plug it here. And let's see what we get. And we get our first cable. If all works correctly, we should be able to get no, because we need to plug this guy here. And enable it. Yes, and with every iteration, we get a new cable. But as you can see, they are using the same points because this is the shortest path. We can avoid that by deleting points, the input geometry. So after using it, cables will delete it. And we can do this by converting our cable into mesh, curve to mesh. So it will be just polyline. And then we can do geometry proximity. Geometry proximity. Two points. And then we can delete geometry and test the distance of the proximity against some value. Compare. So we take the distance and we say less than, and let's use some value of 0.1. This way, after every iteration, we will be deleting some points. So we can preview it. As you can see, these points are deleted that we are used already. So let's see what we get. We get our lovely cables. They are a bit jittery, ruggish, and this is because of how many points are we using, because the connections are straight, obviously. So if we use more points, we will get a more smooth shape. But what we can also do is to convert our points to the NURBS. Set spline type and switch it to NURBS and use it also for the deletion. Then the next step is meshing. We can use curve to tube, which is pre-made node group, which is quite handy. And we need to define the radius. And we can define it also with a random value. So every cable gets a random radius. And for the driver, we'll use number of iteration again. And let's say it will be from 0.5, 0.45 to 0.1. And we can say set curve radius. And our curve is here. Okay. And our radius is here. And what's cool is that this node is automatically picking up this radius. And we have our cables. So I played with some settings, and this is the result I've got from this setup. And as you can see, it's very interesting shape, and you have nice variation between the depths, the radiuses of the cables. Well, I hope you like this tutorial. I hope I'll see you on the next one. And as you probably noticed, I have a new microphone, so I hope the audio quality is better this time. And please let me know if you like it. Also, if you have some ideas about what should be discussed in the next topics, in the next tutorials, please let me know in the comments. I'm always listening and I'm always interested in helping you guys to grow. See you. Bye bye.